So let's have a look at the length of a line segment. So let's, on your graph, on your worksheet, you want to fill this in as we go along. So let's just start by having our lines on here and labeling all of our points. So let's label point A. And remember that this is, the way that we read this is -9, so we count over 9 squares, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then up 9, so 1, 2, 3, 4, 5, 6, 7, 8, 9. So this point is at -9, 9. So let's go ahead and label all of the rest of our points. Point B is -9, 2. Point C is -7, -4. Point D is -7, -9. Point E is -7, -2. Point F is -4, -2. Point G is -2, -7. Point H is 5, -7. Point K is 4, 2. Point L is 7, 8. So notice all of these coordinate points have the x value first and then the y value. Okay, let's have a look. Let's look at what the vertical length would be of any line. So in terms of A, for example, what is the length of this line? Well, you could count it by squares. It's 1, 2, 3, 4, 5, 6, 7. And then how would we find that if we just were given the coordinate points? Well, we would look at just the height. And the height is actually the y-axis, isn't it? So it will be from here minus here. And that's the y value. So 9 minus 2 would give us 7, and that's what we counted. So our vertical length is our y2 minus y1. Let's look at a horizontal line, so this one here. How would we find the length of this? Let's check what it is by counting. 1, 2, 3, 4, 5, 6. It's 7. And 7 is essentially the distance along the x-axis from here to here. So if we were to subtract our x values, and notice we'll go from right to left, so we'll do 5 minus -2, which gives us 5 plus 2, and that's 7, and that's what we counted. So our horizontal length is given by x2 minus x1, subtracting our x coordinates. So how do we find the length of a diagonal line? Because we can't count squares because we're not on a horizontal or a vertical axis, and it's kind of hard to estimate how long this would be exactly. So we're going to use this formula. And what it is really is just a version of Pythagorean theorem if we look at it. Because if I was to drop a triangle down here across this way, my height of my triangle would be this, and my length of my triangle would be this, and then this would be the hypotenuse. So notice that in Pythagorean theorem, if we take this side squared plus this side squared, and then we square root it, we actually get the length of this. So let's look at this. That's exactly what our formula is. Here's the height of the triangle squared plus the length of the triangle squared, and then we square root it, and we get the hypotenuse. So instead of calling it Pythagorean theorem, we're going to get a little bit more sophisticated. We're going to call it L for length of a line, and then we're going to have square root y2 minus y1 squared plus x2 minus x1 squared. Okay? So let's look at how we might use that formula. Calculate the length of the following line segments. So we're given the point 5, 2, and 1, 1. Okay, let's write that out. So we have y2 minus y1 and x2 minus x1. Let's notice what we did here. So we did 2 minus 1 for the y's and 5 minus 1 for the x. Notice that I'm subtracting in the same direction. So whatever point you pick first, subtract both sets in the same direction. Okay, and remember to keep them in brackets and then square them. So what does that give us? 2 minus 1 is 1, 5 minus 1 is 4. We square each. And then we're going to add them and square root. So this will be 1 plus 16, which is square root 17. Now we can leave our answer like that. It's more accurate than writing out a long decimal because square root 17 is not a nice whole number. So we leave our answer like that. Okay, let's try another one. So notice what we have here, y2 minus y1, 6 minus 3 here, and then we have 0 minus negative 1. So be very careful with this. Now we have to use our tidy up rules here. We can't have two signs beside each other. So we get 3 squared here plus 1 squared, and that works out to 9 plus 1, which is square root 10, and we're done. We'll leave our answer like that. Okay, let's try another one. Our y's first, we've got negative 4 minus negative 1 and negative 3 minus negative 2. We've got a lot of tidying up to do here with these two sets of signs first. So this is actually negative 4 plus 1, which is negative 3, and here we get negative 3 plus 2, which is negative 1. And we have to square each, which is 9 plus 1, and that's square root 10. Let's do one last one for good measure. Notice we're subtracting in the same direction, so it doesn't matter which point you start with as long as you subtract both the x's and y's in the same direction. So negative 1 minus 7 and 3 minus 3. Okay, so that gives us negative 1 and negative 7 is negative 8, and that's using our addition and subtraction rules. And 3 minus 3 is 0. We're going to square each, and we get 64. Square root of 64. And we're done. Okay, so that's the length of a line between 2 points on a graph. Oh, this one works out nicely, so we can write 8. Okay, so only get rid of the square root if the answer works out nicely. Okay, let's look at a graphical example. So draw a triangle LMN, and I'll just let you know where those points are. So L is at 3, 2, and M is at negative 3, 4, and N is at negative 4, negative 1. So if you want to pause the video and sketch out your triangle. And then we want to determine what the side lengths of our triangle are. So notice we have to use clear notation because we have 3 sides of a triangle. So side LM, which is here LM, okay, will be 4 minus 2 and negative 3 minus 3. Okay, and you can subtract in either direction. It doesn't matter as long as you go the same way for both coordinates. Okay, so that works out to 2 squared plus negative 6 squared. Always keep them in the brackets because notice it affects the negative sign. So we have 4 and 36. That's added, we get 40. So square root 40 is our length. Let's do side MN, M and N here. Okay, we've got, we did negative 1 minus 4 and negative 4 minus negative 3. Be careful here of the signs. That gives us negative 5 and negative 1 squared. So we get square root 26. And our last side is NL. And what we did for that one, NL, we did negative 1 minus 2 and negative 4 minus 3. When we tidy that up, we get negative 3 squared and negative 7 squared. And that gives us square root 58. So we've calculated the length of each side of the triangle. And from there, we want to determine the type of triangle. So we would analyze the lengths of the 3 sides. If all of these 3 answers were the same, it would be an equilateral triangle. If 2 of these sides, any 2 were the same, it would be an isosceles. But since all 3 of these sides of the triangle are different, we're going to call that scalene. It means none of the sides are the same. Okay, let's do a thinking type of question. Now this one's a little bit more difficult. We'll do 2 examples. This time we have to work backwards. Our question here says determine the possible coordinates of the endpoints of a line segment with each length. So this time they give us the answer to our length formula, and we have to figure out what the x and y of each coordinate point would be. We have to come up with 2 points on a line that would give us an answer of 6. So this is a little bit tricky. So what we're going to do is we're going to set up our formula, and our answer is going to go here. This is our answer part, our length equals, okay? And for these types of questions, the answers are going to vary because there's lots of different answers. Now, SBS means square both sides. We're going to square both sides to get rid of that square root sign. So if I square this side, I get rid of the square root, and 6 squared is 36. So this is starting to look a little bit better. Okay, so now what I want is I want something in this bracket squared plus something in this bracket squared to equal 36. And the easiest thing to do is, let's check if this works. So you could have different answers here, but this one is, you want the simplest one. So 6 squared plus 0 squared, let's see if that works. And this is a little bit of guess and check at this point to come up with these numbers. So 6 squared is 36, 0 squared is 0, so that does work. Okay, so we're not quite done yet because the question was come up with 2 points. So now I have to come up with my y2 and my y1. I can put 2 numbers in here that would have given me 6 and 2 numbers in here that would give me 0. So any 2 numbers that subtract to 6 and subtract to 0 will work. So here's where you can get all kinds of different answers. So let's see, what did I come up with? To get 6, I came up with 7 minus 1, and you could have put lots of different numbers in there. And to get 0, I put 1 minus 1, just keeping things nice and simple. So what are my coordinate points? I still have to write them out. And how did we come up with that? So notice here we had an x2 and an x1. So my x1 and my y1, where are those? My x1 is here, so that's 1. And my y1 was here, so that's 1. So I have 1 comma 1. And where's my x2 and y2? My x2 is here, and my y2 is here. So notice that those are the first numbers. So I have 1 comma 7. Okay, so here's my 2 coordinate points. So I just did the whole question backwards, and that's a little bit tricky. Let's do one more example of that, because it's not quite that easy. So here's our answer. Our answer is square root 17. Remember, we don't write that as decimals. Our final answer was written with a square root. So we'll put that square root here and set up our formula. And we want to square both sides. That step is still the same, so we get rid of the square root signs. Notice that the square root of 17 squared means that the square roots just cancel each other. So here we've got something that's starting to look better. Now I have to come up with 2 things in the bracket that will give me 17 when they're squared. So 4 squared is 16 plus 1 squared is 1, so that's 17. So those 2 work. So that's the thinking part there, a little bit of guess and check to come up with 2 numbers. You may have come up with some different things, but that seems to be easiest. Okay, so any 2 numbers. Now here's where you come up with any 2 numbers that subtract to 4 and subtract to 1. You can think of lots of different things, but I came up with 7 minus 3, that gives me the 4, and 0 minus 1 gives me the 1. Well, gives me negative 1, but that's fine because it's squared anyway. So now we have to write out our points. So notice that these are my x1 and y1s here. So I write 1 comma 3, and these are my y2, my x2 and my y2 is here. So I'm going to write 0 comma 7 for my x2 and y2. So here's my 2 coordinate points, and you can go backwards and check them and see that they do work to give you an answer of square root 17 for the length.